In this video, we will be talking about solving equations containing a rational exponent. So first of all, let's refresh our memory on the power rules. So whenever I have a base to a power raised to some other power, I can rewrite that as an times m. So I multiply the powers together. We will be using this property, but for rational numbers. So for instance, if I have a to the 1 over n times m, this is equivalent to a m over n, raised to the m over n power. So now another property we should be familiar with is whenever I have a to the rational of 1 over n, the 1 has to always be in the numerator and then some constant on the denominator. This could be rewritten as the nth radical of a. So for example, if I have a to the 1/2, this is the same as the square root of a. If I have a to the 1/3, this is the same as the cube root of a. If I have a to the 1/5, this is the same as the 5th root of a. Now let's use these properties to solve this equation. So here I have x to the 5/4 equals to 32. So now here I'm trying to solve for x. Whenever we're trying to solve for something, for a variable, we're always solving for one variable. So here I need to obtain one x on the left-hand side. So here, in order for me to obtain an x, the power here is 5 to the 4th. So I will be multiplying, or I will be taking the reciprocal power of 5 over 4, which is 4/5. Whatever I do to one side, I have to do to the other. So now here, x to the 5/4 to the power of 4/5 gives you x, because 4/5 times 5 over 4 is 1. And now I need to work on the other side, which is 32 to the 4/5. Now I need to rewrite this in a way that is easier for me to evaluate 32 to the 4/5 without using a calculator. So here I am going to use the exponent property, and I'm going to rewrite this as 32 1/5 to the 4th power. Now 32 to the 1/5 is basically the 5th root of 32 raised to the 4th power. Now the 5th root tells you, just like the square root tells you, every two numbers that are identical underneath the root comes out as 1. The 5th root tells you every 5 numbers that are identical underneath the root comes out as 1. So this right here, I know that I have 32 could be rewritten as 2 times 2 times 2 times 2 times 2. So notice right here, I have 5 2's underneath the radical. So that comes out as 1 2. So this is equal to 2 to the 4th power, and 2 to the 4th power is equal to 16. So this tells me that x is equal to 16. You can always check your answer by plugging back in the value for x into the original equation, and you're supposed to obtain 32. Now let's look at this equation. So I have 3x to the 3/4 equals x to the 1/2. So my first step is I'm going to subtract x to the 1/2 from both sides. That gives me 3x to the 3/4 minus x to the 1/2 equals 0. Now I'm going to factor out a greatest common factor, which here happens to be x to the 1/2. So when I factor x to the 1/2 from the first term, the 3 stays, and now x to the 3/4, factoring out is just the same as dividing. So whenever you're dividing and you have the same base, the way you divide this term is you subtract the exponent. So that gives you x to the 3/4 minus 1/2, and that equals to x to the 1/4. So now x to the 3/4 factor out x to the 1/2, you would have x to the 1/4 left. Minus 1 is equal to 0. Now, using the 0 property tells us either this factor has to be 0 or this factor has to be 0 in order for the whole equation to equal 0. So now I separate it to x to the 1/2 equals 0 and 3x to the 1/4 minus 1 is equal to 0. Now here, we square root, so here we have x to the 1/2, which is the same as the square root of x equals 0. So I take the square of both sides. The square gets rid of the root, so that gives you x is equal to 0 as one solution. Now the other side, I need to isolate x, so I add 1 to both sides. I have 3x to the 1/4 equals to 1. And now I divide by 3, so x to the 1/4 equals 1/3. And now I take the reciprocal of the 1/4, which is 4. So I take the power of 4 of both sides, leaves you with x equals to 1 over 1 to the power of 4 over 3 to the power of 4. And that equals 1 over 81. So now in both solutions here, I have x equals 0, x equals 1 over 81. We can always check our solution by plugging it back into the original equation. Let's look at this equation. So I have x plus 5 to the 3/2 equal to 8. So the first thing I need to do in order for me to solve for x is I need to get rid of this 3/2 power. And in order for me to get rid of it, I need to take the power to the 2/3, and whatever I do to the one side, I need to do to the other. So now by doing that, 3/2 times 2/3 gives you 1. So now you have x plus 5 on the left-hand side of the equation, and you have 8 to the 2/3. So before I move on, I need to obtain a number or a value for 8 to the 2/3. So the way I am going to do this is I am going to rewrite this as 8 to the 1/3 squared. So I'm separating the exponent, the rational exponent. And now here, I am going to rewrite this. So 8 to the 1/3 is the same as the cube root of 8 squared. So x plus 5. Now the cube root of 8 is 2. Remember, every 3 pairs underneath the radical comes out as 1. So now here we have 2 squared. And now I have x plus 5 equals to 4. To solve for x, I subtract 5 from both sides and you get x is equal to -1. And that is the only solution for this equation.